So my first challenge is going to be to turn a bunch of scrap material into a 250-pound combat robot. The scrap material I'm using is all coming from a fitness supplier. Now these are all second-hand material that is absolutely unusable, unresellable, so they give me special permission to dig through their dumpster and to turn out a combat robot. Here we go. So the first phase, of course, is to strip it. So this tower here is going to be my main chassis member. So I've got to chop off the bits on the side and some tidying up on it to do, but that's going to be the structure of it. And the other bits that are down on the floor here, they're going to make some additional support. Now what I'm thinking is that the outright arm with the thingy there, that might be the right size for what I'm looking for. But I gotta check. Probably isn't, and I'll probably end up having to use something else. However, the other important thing is I got these rods here, a 20mm thick. They're what the weight stack slides up and down on. They are a high carbon chromoly steel. It's fucking brilliant because I can use those for shafts and all kinds of stuff. So they're a really, really good find. The pulleys and stuff, they come with a flat belt. Now it's not a continuous flat belt, I'm going to have to make it into a round belt, a continuous belt myself, but I'm going to use that to power its weapon. Yeah, that's it for now. Everything else is trash, so it's tidying up time. So let's see whereabouts we are. So this is condensed some of the stuff that I have salvaged from the scrap heap, things that were unusable, things that are come off machines that worked but had other things wrong with them. So the treadmill motor there came off a treadmill where the deck was broken and the supports for the deck were broken off with it, so the motor was fine, the deck was no good. That included the actuator, which is down here, but I'll go into that in a second, and another one where the motor had gone but the actuator was fine. This frame was off a leg extension curl where one of the lifting pivot points had sheared completely because 2 bearings had gone, and this brand, they're a bit US. We don't really do anything with them. That's another matter. The wheels that you can see right here, 4 of them, they are off of a Stairmaster, one of those machines that you climb up on stairs. And those are actually, they come with the machine, and they're for moving it around. They come on this pin, which goes through it, and it's got this little clip on the other side. And once it's in position, you take the wheels off, and that's it, it's in position. So they're scrap. They get thrown away after then, so I had them. So, roughly the plan is to turn this frame into a vert using this 45 pound, 20.4 kilogram weight. It'll be a little bit further forward than where it's currently sitting. I'm going to use the 2 actuators that I've got, which are not the same, but very similar, to drive the gearbox, to drive this shaft here. What I wanted to do was to turn this shaft completely around, but that would mean modifying the back of this so much so that it was unrecognisable. And I thought, screw it, I can just put it on the end there, put the wheel on the end there. So one of these wheels will get connected to, well, one of the wheels will be connected to this, but via the 2 shafts that I have over in the corner there. I'll come back to that in a second. This big guy here is going to belt drive this hunk of chunk here, and it's going to be off a pivot here. This is steel. This is a steel plate. And I'm not going to put teeth on it. What I'm going to do is I'm going to chop the handles out and use the edges of the handles as the hitting points, which means engagement is going to be a bit strange on it, but it'll be fine. The other thing I've got to do, I have to do, is I have to take off all of the logos here and all of the information down at the bottom here too. Why? Because these take it out of balance. And balance is super important when it comes to spinning weapons. So the other thing, this guy here, this is a 90 volt permanent magnet DC motor, which means any direct current voltage you put in will turn that motor. Anything from, like, I think about 5 volts will actually make it move as long as you've got the current to back it up. I'm going to run that on about 48 volts, the same as the motors here for drive. Now let's talk about that for a second. So as you can see, this is not off of a treadmill. So the motors that come on the actuators are they're 110 volt AC motors. They're great motors for what they do. However, for a BattleBot, I'm going to have to use something else. I'm going to have to change the can for a more regular brushless motor, which this is a Maytech one. I happen to have a few of these because I bought them to try in the robot in Foxtrot, and I ended up going with my own motors that I made, which, funnily enough, were made from actuator motors that I found. Anyway, they have a gear, a helical gear, cut into the shaft on the motor that goes there. It just so happens that the shaft that goes in here normally is 8mm, which is the exact same size as the shaft in the Maytech. So providing it's long enough, which I think it is, I think it's just a bit too long actually, but I can deal with that. I will knock the shaft out of the Maytech motor and replace it with the shaft that comes with the motor that is usually in there. Now, this gearbox here is surprisingly all metal. Usually I think they're plastic, but whatever. This is an all metal gearbox in here. It drives this lead screw here, down here, and this lead screw does all of the driving. So usually there's a nut on there, on a tube, and it pushes up and down, and it raises the treadmill up and down. Well, I don't want that, obviously. I'm going to attach a pulley on here that's going to be stuck on and it can't go anywhere. That pulley is then going to drive the wheels, one at the front and one at the back. We've got another 2 of those wheels just there. So it will be 4-wheel drive. Now, I'm going to do it by pulley because I need to do a different ratio. These are rated to 47 RPM output on the motor that's usually there. So the motor that's usually there is about a 2,500 RPM motor. This is a 7,500 RPM motor on 12S, which makes these are fast. So the torque will be there, but the speed won't. So it'll be, well, it's about 3 times the speed. So let's say 3 times the speed there, which means 150 RPM there. So 150 RPM on 6-inch wheels means it's going to be about 2 or 3 miles an hour, which is ridiculous. It's probably not quite that slow, but it'll be too slow. So the ratio is going to be a 3-to-1 ratio. So the pulley will be 3 times larger than it is on the wheel, so they will go 3 times faster than the shaft output there, which should give it enough speed to make it move around. The torque on this should be more than enough to move the robot. Worst case scenario, all of that fails, and I will put Foxtrots, 2 Foxtrot drive motors in the back here somewhere to drive it around. That is worst case scenario. I do have a slight issue in that these here are, well, they're 6.5 inches. And the plan was for it to be invertible so that, it could run both ways up. But this is bigger than this. So the wheels are a little bit shorter, just a little bit shorter than the actual thickness of the material. So I'm going to have to do something I didn't particularly want to do. It's going to be a long job to do it, but I'm going to cut across the top here, down there, about 1.5 inches depth on both sides and on the other side. And I'm going to drop the height of it down so that the robot is then invertible. Now I've got pivot points and stuff all around from the other material that you saw me cut up last week. The other thing I've got down here, that is a roller for the back of a treadmill. So the front treadmill has a roller which is belt driven off the front. That's the front roller. As you can see, the pulley on the front. That pulley, a bit big for my liking. I do have one with a smaller pulley around here somewhere, right here. Just there. And the thing is that they have angular contact bearings in them, which is really unusual. I don't know why they would need it, but they have them. Surely roller bearings would be fine, but I don't design treadmills. That's somebody else's job. Anyway, what I'm going to do is I'm going to cut the bearings out at the top and cut the bearings out at the bottom. Get rid of the bit in the middle, which I don't need. And then I'm going to put the end of that on one side of here and the end of that with the pulley on the other side. It's going to be pulley driven. It's going to be a pulley driven robot on the weapon, and that's the motor that's going to do it. I'm going to use that to spin it. They're really, really cool motors. That one does seem to work, which is great because there's a lot of work to do, but that's the plan. So the first part of my challenge is to get all the parts together, identify what it is I'd like to make, which in this case is a vertical spinner, and basically get started. So in the next video I'm going to start chopping up parts, and I'm going to hopefully start turning a pile of junk into a usable 250-pound combat robot.